So on this module, we're going to talk about FHRP. First hop redundancy protocol. So many times it's necessary to have more than one way out of your network for redundancy. Redundancy is a very big thing, having more than one way out, as you could well imagine. End devices are typically configured with a single default gateway IP address, as you know. But if the default gateway router interface fails, then LAN hosts lose outside LAN connectivity altogether. This occurs even if a redundant router or layer 3 switch that could serve as a default gateway exists, because it is looking for one particular device as its gateway because we have defined it as such when we did our configurations. So first hop redundancy protocols are mechanisms that provide alternate default gateways in switched networks where two or more routers are connected to the same VLANs. So one way to prevent a single point of failure at the default gateway is to implement a virtual router. So to implement this type of redundancy, multiple routers are configured to work together to present the illusion of one single router. So in essence, you create a group of routers. By sharing an IP address in a MAC address, two or more routers can act as a single virtual router. The IP address of the virtual router is configured as the default gateway for the workstations on a specific IP4 segment. So when frames are sent from host devices to that default gateway, the hosts use ARP to resolve the MAC address that is associated with the IP4 of that default gateway. The ARP will return the MAC address of that virtual router. So frames that are sent to the MAC address of the virtual router can then be physically processed by the actual current active router within that group. So a protocol is used to identify two or more routers as the devices that are responsible for processing those frames. So your physical routers are still going to do their physical capabilities. The thing that your router is there to do is to route your packets from source to destination. So those parameters don't go away. So what happens is you define an active router, you define a standby router to take over if the active goes down, but you also create a virtual environment. So host devices send traffic to the address of that virtual router. The physical router that forwards the traffic is transparent to the host device. Your host device, only knows what you tell it. So a redundancy protocol provides the mechanism for determining which router should take the active role in forwarding your traffic. It also determines when the forwarding role must be taken over by your standby router. The transition from one forwarding router to the other is transparent to the end device. The ability of the network to dynamically recover from the failure of a device acting as a default gateway is known as first hop redundancy. So in a first hop redundancy environment, you have an active router. This is the physical device that actively forwards your end user traffic. Then you have a standby router. Your standby router is your backup device. It listens for hello messages and it is ready to take over only if your active router goes down. So when the active router fails, the redundancy protocol transitions to the standby router, as shown in this figure here. The virtual router would have its own IP, but a virtualized MAC address. So these are the steps that take place when the active router fails. So the standby router stops seeing hello packets. When it stops seeing hello packets, it realizes that something is wrong. So it jumps in and it assumes the role of the forwarding router. Again, the physical forwarding router. So it takes over for forwarding those packets. Because the new forwarding router assumes both the IP4 and MAC address of the virtual router, the host devices see no disruption whatsoever in service. So each router in the group is assigned a priority value between 0 and 255. If no priority is explicitly set, the device assigns the default priority of 100. So HSRP, which is Cisco's version of FHRP, provides gateway redundancy by creating, again, a virtual IP and a virtual MAC address shared between multiple routers in a group. One, again, acting as the active, while the other becomes the standby, ready to take over. Now, hot standby router protocol. Proprietary, Cisco. It is an FHRP designed to allow for transparent failover of first hop IP4 devices. It is used in a group of routers. Typically, it's only 2 physical routers, but it could be more. It is used for selecting an active device, again, the one that is going to be doing the physical forwarding, and a standby device, the one who is going to be listening to make sure the active does not go down. The active device is the device that is used for routing packets. The standby device is the device that takes over when the active fails, or if certain preset conditions that you could define are met. You have HSRP for IP6, where, again, Cisco proprietary, but in an IP6 environment, the group has a virtual MAC address derived from the HSR group number and a virtual link local address derived from the HSRP virtual MAC address. And there are periodic router advertisements that are sent out with that information. Then you have virtual router redundancy protocol. This is a non-proprietary election protocol that dynamically assigns responsibility for one or more virtual routers to the VRRP routers in a LAN. So this allows routers on a multi-access link to use the same virtual IP address. So in a VRRP configuration, again, one router is elected as the virtual router master, with the others acting as backups in case the virtual master goes down. In version 3 provides the capability to support IP4 and IP6 and works in multi-vendor environments and is more scalable than 2. Then you have Gateway Load Balancing Protocol, GLBP. This also is Cisco proprietary. It protects data from a failed router or circuit like HSRP and VRRP, but it also allows load balancing or load sharing between groups of redundant routers. Then you have it for IP6 that provides the same functionality of GLBP, but in an IP6 environment, it provides automatic router backups for IP6 hosts configured with a single default gateway on a LAN. Multiple first hop routers on the LAN combine to offer a single virtual first hop router while sharing packet forwarding. And then you have ICMP Router Discovery Protocol. Specified in RFC 1256, it is a legacy FHRP solution where it is allowing IP hosts to locate routers that will provide IP4 connectivity to other non-local IP networks. So different variations of first hop redundancy protocols. So an overview of HSRP. Again, in HSRP for IP6, they are Cisco proprietary. They are designed, again, as a first hop redundancy protocol allowing transparent failover. So it ensures high network availability by providing first hop routing redundancy for IP hosts on networks configured with IP default gateways. It is used in a group of routers for selecting an active and a standby. So in a group of device interfaces, the active device is the device that is used for routing the packets. The standby device is there only to take over if the active goes down, or if there are preset conditions defined by you. The function of the standby router is to monitor the operational status of the group and to quickly assume packet forwarding if the active goes down. So the role again of your active and your standby is determined during the election process. By default, the router with the highest numerically configured IP4 address is elected as the active. However, it is always better to control the election yourself. So we could utilize the HSRP priority and determine the active router. So the router with the highest priority will become the active. By default, your priority is 100. So if I go into, as you see here in this example, R1 and give it a priority of 150, it becomes the active, and R2 becomes the standby because it only has a priority of 100. So if the priorities are equal, the router with the numerically highest IP4 address will be the active. To configure a router to be the active, use the standby priority interface command. The range of priority again is 0 to 255. By default, after a router becomes the active router, it will remain the active router even if another router comes online with a higher priority. To force a new election, you would have to do a preemption. So preemption must be enabled using the standby preempt interface command. Preemption is the ability of the HSRP router to trigger the re-election process. So with preemption enabled, a router that comes online with a higher priority will assume the role of the active router, but only if standby preempt is configured. Preemption only allows a router to become the active router if it has a higher priority. A router that is enabled for preemption with equal priority but a higher IP will not preempt. So with preemption disabled, the router that boots up first is going to be the active if there is no other router online during the election process. Now, HSRP has states and times. So your initial state is entered through a configuration change or when an interface first becomes available. After that, you go to a learning state. In the learning state, the router has not determined the virtual IP address and has not yet seen a hello message from the active router. In this state, the router waits to hear from an active router. In the listen state, the router now knows the virtual IP address, but the router is neither the active nor the standby. It listens for hello messages from those routers. In the speak state, the router now starts to send out periodic hello messages and actively participates in the election of the active and the standby. In the standby state, the router is a candidate to become the next active router, and it also sends out periodic hello messages. It does this to ensure that the active router is still there. So the active and standby routers send hello packets to the group every 3 seconds by default. Your standby router will become active if it does not receive a hello message from the active after 10 seconds. You can lower these timer settings to speed up the failover or the preemption. However, to avoid increased CPU usage and unnecessary standby state changes, do not set the hello timer below 1 second or the hold timer below 4 seconds. Oh, I'm sorry, the hello timer not below 1 and the hold timer not below 4. So HSRP is not really difficult to to configure. Understanding it is a little bit more difficult, so hopefully you should watch the video that I put out there for you with regard to those protocols. It pretty much determines that you have a group of routers, 2 or more. One is elected as the active. The active is going to do all the forwarding for the network. You have a standby that is there just to listen to the active. If it does not receive hello packets from the active, it will assume the role of the active. Your virtual is set with an IP address in a default gateway so that your end devices never feel the impact of your active router going down. So your virtual router does not do routing. It is only a gateway for your end devices to get to the destination. We create a virtual environment so that, regardless of the active going down, your end devices always have a gateway to get out.